Good afternoon, everyone. So we'll start continuing our learning to attention and transformer. So this is very important lesson and course because modern neural network all using attention and transformer recently. In the convolution neural network, there are many variants of Fission transformer. In natural language processing, there are many language models that you will have to explore. But today we will learn a basic concept of attention and transformer. After this course, the rest is just architecture. Like you can see many architecture of Fission transformer or NLP transformer, including ChatGPT, is powered by GPT model. GPT is generative pre-trained transformer. Okay, there are many other models like Palm or Llama, or you can see more on the Hugging Face. Yeah. So Hugging Face is a community website for transformer neural network. Hugging Face. It provides you model library collection. It also provides data set. And of course, it provides a very famous transformer library that you will have to learn during the course. Okay, so let's start. So attention comes from the fact that many neural network before, you have to read chapter 11, by the way. So many neural network before required you to have a fixed size of input. For example, LSTM and GRU that you learned last week, modern recurrent neural network. The problem is the size of the input must be fixed. If not, if you don't have entry on the input factor, you have to set some null value. And of course, it's not AI cannot be like that. So the solution for this is an attention mechanism that actually proposed by Bahdanau, yeah. But there is a story about that. So you have to visit this folder in our material drive. Let's start by the story from what you are familiar with, okay? So take a look on this eye. This is how your eyes is working. So if there is an object in front of you, the object will reflect the electromagnetic wave, and then your eyes, which is a very complex system, from cornea, iris, pupil, lens, and up to your neurons and brains connectivity. So if you see an object in front of you, like this glass and some stack of paper, your attention is not same on all objects. You must be focused on one, okay? So you cannot distribute your attention in the same portion of all of these objects in front of your eyes. Like if you are reading a book, you are not focused on all words. You are focused on one words at one time, and then you are moving from one words to another words while you are reading. The same thing with this, okay? You're focused on this class. You are not focused on other thing, okay? So our AI before attention is actually is not natural, because even small animal like this one, they can focus. They have sensor and they have focus on attention focus. So not only fixed size as a background problem of attention, but also all AIs say that they have the same focus on the features of the data. So that is why we in neural network, we try to implement attention for a long time back, okay? So I will use this slide to explain attention mechanism. And I hope after this my talk, JC can start introduce you transformer library using ChatGPT prompt engineering. So the motivation starts from machine translation like this, yeah. But actually, historically, attention comes from computer vision. When we try to make object recognition, but the model it don't have attention. So, but this case is from NLP. So each generated token usually have to be able to be related to one original source of tokens, like hello word in, let's say, in English, okay? And then you will translate to bonjour le monde. This is in France, okay? And if you see here, hello word, hello and word, but this one is 3 words, okay? So there is a fixed size tree here. If you need to have more sentence, you have to make a larger token as input, okay? So this is one of the problem that is explained in this chapter, chapter 11. And then that is one of the background why we need to have attention mechanism. So attention mechanism, imagine if you are interacting with database. Let's say in your database, there is a table, yeah? And then you can do query based on keys, yeah? So you can focus your query based on specific value. So key value query. So the idea is quite similar with database, but implemented as a mathematical concept, yeah? So with attention layer in neural network, yeah, you can explicitly select related information by setting the value of your query, okay? So attention mechanism, attention layer is memory, like a memory, consists of key value pairs, like when you're interacting with database, you have key, you have value, and you have query, yeah, to the database. And based on key value query, you get the output. So think of attention layer as a key value query, like a memory with key value query. So the mathematical formulation, if you read the book, D2L book, is formalized like assuming the query is vector and the memory is a tuple of query and value. And we need to compute n score of attention score, yeah? So attention is implemented as a score in mathematical formulation. So let's say n score of A, index 1 to n, we call it attention layers, yeah? So it used some mathematical function like softmax to make sure that the output is normalized as a probability. The output is weighted sum. So the output of the attention layer is multiplication between B, bias, and value, okay? You don't have to memorize all of the mathematics, but I really suggest you take pencil and papers and read the chapter 11. So you have faced the process of derivating the attention mechanism as a key value query, okay? So this is the background, and then it's implemented here and visualize attention mechanism here. So as neural network is consists of many layers of vectors, so attention layers is additional layer that you can do key value query inside the neural network to make sure you have some focused attention, okay? So if you query based on specific value, that means you focus on the specific value in your query and you can get different input. So attention mechanism translate this as a linear combination of value via attention pooling. So there is a pooling mechanism. where the weights derive from the compatibility between the query queue and keys chart. Okay, so it's a vector operation. So you have to be familiar with the vector operation of attention layer. Okay, so how we implement this basic concept into neural network? Yeah. So let's say we say that the attention is a perception layer or attention layer. Yeah. Initially, neural network is just weight parameters W. Okay. We have the same attention on each W. Let's say you implemented multi-layer perceptron. Okay. So each element of the W is the same focus, which is not natural. Okay. What about if you put attention layer? That means you have alpha KQ equal to V, which is value, key query equal to value, and then activation tanha and normal weights, yeah, WK and WQ. Okay, so this is how we implement the single hidden layer perception using attention. So you change this, instead of directly to this, you add key value query to the layer. Okay, so you can use ChatGPT. So let's say you can say act as an AI engineer. Okay, implement write PyTorch code to implement multi-layer perceptron with modification with attention layer in the MLP. Okay, make synthetic dataset for classification and implement neural network MLP based classification with and without attention. With and without attention. Okay. Then compare the result. Accuracy. So MLP, if you implement simple attention layer, just change key value query. Yeah. This is MLP with attention. Of course, you have to understand where they put the self-attention part, attention weight, and without attention. And then you can compare, and then you will see what happened. Okay. So amazing concept. Yeah. So let me continue. Sequence to sequence with attention. We already know this sequence to sequence architecture, usually using encoder-decoder architecture. There is a LSTM as an encoder, there is LSTM as a decoder, there's a hidden state at the middle. So, but how you put attention into sequence to sequence architecture? So to put additional attention layer, yeah, we have to consider to put it on the both sides, attention output and the decoder and attention at the encoder. Okay, so usually they put some additional layer that cross over the encoder and decoder. And if you see attention layer here, again, think of key value query. Okay, so in detail, it's like this originally. So we have sources, and then from source we make embedding vector. And then from that, we stack LSTM or GRU layer. And then we put some attention layer at the top of the encoder. And this attention layer will do key value query together with the decoder. Okay, you see here, there is an arrow from recurrent layer on the top of encoder. And also there is an arrow entry from the decoder. Okay. So with the same format of this, you can try. Okay. So I act as an AI engineer. Python supposed to implement sequence to sequence. Can architecture a model for machine translation. You can stack LSTM, or maybe you don't have to say sequence to sequence, but encoder decoder. With attention layer, okay? Make synthetic data set for machine translation and implement encoder decoder model based machine translation with and without attention, then compare the accuracy. Okay, so it's very common architecture long time back. Okay, next, let the AI works, and then I will let you fix the code if there is an issue. But what you have to see in the code, where is the key value and query during the implementation. Okay, it's very easy concept actually, that instead of you use learnable weight parameters, you have to make some attention pooling, like the weight parameters of the neural network becoming key value query. So you can add more, you can learn more parameters of key value queries. Okay, let me continue. So transformer. So we start in attention is all you need. There is a paper submitted by Google engineers. Attention is all you need. Yeah. So he is actually the one who found transformer neural network. Attention is all you need. Paper. Okay. So you have to remember his name. His name is Vaswani from Google. Okay, not from OpenAI. So Vaswani, maybe this is his PhD thesis or maybe not. So many of people here is a very top AI engineers from Google and Toronto lab. So he said, actually, attention is very universal, and this is what you need in neural network. Okay, but how you model the architecture? He proposed this very famous transformer model architecture. And then he said, this architecture contains encoder, decoder, okay? But it can be replicated n time with n is up to you, okay? Initially, if you build using LSTM, encoder, decoder with recurrent neural network like LSTM, so many problems with the embedding because the input is fixed size. He proposed, let's use positional encoding as additional of input embedding. Okay, so instead of just input embedding, make another encoding for positional, so you don't have to worry about the size of the input. Let the positional encoding cover that. Let's say from English to German language, there is a different size of vector of machine translation, then positional encoding will work on that. And then implement multi-head attention, perform addition and normalization, and just use feed-forward neural network. You don't have to use LSTM or GRU. That's too much. Okay, just use MLP or feed-forward neural network. Okay, but in the encoder part, you have a multi-head attention. In the decoder part, you have to implement mask multi-head attention as an input of the embedding. Okay, so this is very famous architecture that we know as transformer in currently. Okay, so first the key idea in the transformer neural network, self-attention. Okay. So to generate an output with an input, we can copy each input into key value query. So just think self-attention as a key value query. No sequential information is preserved in this memory and just run in parallel. Okay. And then transformer architecture from Vaswani say it's encoder-decoder architecture, but the N here, the transformer block, you can add as many as you need. If you have bigger data, you have bigger N, okay? So from sequence to sequence architecture on the left, you see what is changed. There is no recurrent layer. It's just multi-head attention and some additional encoding for positional and position-wise feed-forward neural network. Instead of using recurrent, it's just proposed feed-forward neural network. But it say here, position-wise means that this multi-layer perceptron or feed-forward neural network is aware about the position encoding. Okay, so you have to look on the code and see what is the position-wise FFN. The rest is normalization and addition operation. And then transformer block, which is you can get transformer block in PyTorch or TensorFlow. You can make your architecture as many as you need, n time. Okay. Once you have the network trained, you say pre-trained transformer, and there is a lot of pre-trained transformer model available. Not only GPT like GPT 3.5 or GPT-4, but there is a lot of pre-trained transformer like PaLM, Llama, Vicuna, okay, Mistral. You can find in Hugging Face. Okay, so for language model, there is a open leaderboard transformer for language model. Many companies make their own language model. And they share it for free as an open source. So you can build your own language model. Of course, to achieve the quality like ChatGPT or Gemini, you need a lot of resources for data annotation. But the basic model, the foundational model is available here. So many, okay? It tested on many language data set, okay? So is open knowledge. Once you learn about transformer library, you can explore the jungle of the LLM or large language model. So multi-head attention is kind of a self-attention concatenated together like a factor operation of multiple attention that you combine. Okay, so don't worry about this detail of the architecture because in the programming side of the transformer, you just you have the transformer block already set up by the framework. Okay, so position-wise feed-forward neural network is a reshape input. You remember feed-forward neural network, but the input is reshaped. Okay, batch, sequence length, and fee size. Okay. To make sure that is can align with the positional encoding. At-end normalization is similar to batch normalization that we learned this in convolution neural network, but with mean and variance are actually calculated along the last dimension. Okay. What next? Positional encoding. So assuming the embedding output is X with shape, yeah. So it's kind of a transformation for positional. So X plus P, the output, but the P we learn from the data with this kind of a mapping using sin and cos. Okay. So why they're using sin and cos is to translate the position of the vector to make sure that each vector don't have to be fixed size. So then we predict to predict at any time t in the sequence-to-sequence architecture, the input of the previous time as a key and value, and the input at time t as a query. So think of the input at time t is the query, yeah, to self-attention layer. For the code, you can ask ChatGPT, yeah. So I will use the same here. Act as an AI engineer to implement transformer, simple transformer based machine translation from English to Indonesian language. Okay. Max syntax for machine translation. And then implement encoder this transformer model for machine translation. Okay. And report the accuracy. So many people write code in GitHub. So I think you can try making simple corpus, not random number like this. So ask the ChatGPT to make simple corpus, and then you can see how it's implemented using PyTorch in the simplest form. Okay, but of course, in real world, we don't deploy this kind of code. You will work with many transformer-based model in Hugging Face. Hugging Face provide many transformer model for many tasks in NLP. In computer vision, you can just call, as long as you know how to use the library, you can call the model, pre-trained model in Hugging Face. Hugging Face provide model hub, dataset collection, and library. Okay. The best way to learn this is to start from the documentation. There is documentation about transformer library. I will make this as your homework. Okay. For this week. And JC will help you to start with this tutorial. After you know about this, you can learn about the NLP using Transformer Library. There's another course here about NLP, including the language model. Yeah. So, but please start with this Transformer Neural Network course, and then you can find another course here in the Transformer Hugging Face website. Okay, I will continue the material while ChatGPT is code for us. Yeah. So BERT. So initial architecture using transformer called BERT. Okay, bidirectional transformer. So it's BERT architecture is just like this. It can use initially motivated by computer vision, that let's say there's an image, there's a layer of convolution to extract the features and classifier. So why we cannot use this for NLP? So how to implement the features extractor layer for NLP? So can we use transformer? Yes. So BERT is the architecture that implement for classification, like sentiment analysis or simple classification tasks using NLP, that using transformer encoder only, not with the decoder. Okay. So with the transformer encoder, the BERT model can have a language, you can make language model or machine translation using BERT. Yeah. So very easy to implement. You can find many BERT model in here. Just go to text classification, and then you will see many BERT, Roberta, all of the variant of BERT. Yeah. So all of the state-of-the-art model already reproduced in Hugging Face. So you don't have to implement from scratch. You can pre-train, use the pre-train. You can train from your data. You can tune the pre-train. You can perform fine-tuning with your own data in Hugging Face. So it's very important library for AI engineers nowadays. Okay. So you can implement many question and answer, machine translation, making your own language model using Hugging Face Transformer library. So this week is dedicated for you to learn Transformer library. You can just pip install Transformer, but I will hand over to JC to guide you getting started with Hugging Face and Transformer library during the next 30 minutes. The result of this course will be on your side. As much as you practice the course in Hugging Face, you will get more than what I can give to you during this course. So spend your time, do your homework on a course, a Hugging Face course. There is two course. One is about NLP, one's about Transformer library. So you can search the NLP course, Hugging Face. This is where you can implement sentiment analysis, question and answer using pre-trained network. Okay. Okay, so natural language processing. This is the course, NLP course and Transformer course. Please spend time. 1 week is enough for these two course. I hope you will see amazing words in Hugging Face. Yeah, it's very active community, open source, and you can get more of your excitement in Hugging Face. Thank you. So please, Jesse, continue with Hugging Face Transformer library.
Thank you. Let me share my screen first. 1 second. Okay. So, welcome everyone. Welcome to the practical session of this course. And today we will try to explore a little bit about Hugging Face and also try to implement the attention transformer on the one of the models listed on the Hugging Face. So, uh, in this side, let me copy this link first. If you are not familiar with this site, this is the GitHub for not only just GitHub, but the hub for uh, datasets, models, and many more. Like, let me see. Okay. Uh, and this this website there are listed like datasets you can use to train your models from scratch, and there are tabs for models. Uh, this is models someone's already trained for us. Uh, so you don't have to train it from the beginning, and some of these models trained from millions upon millions of datasets, which theoretically not impossible, I mean, but it will take a lot of resources and money, of course, to train it by yourself. Like, let's see if there's any example of like this one. Uh, this one trained with 132 billion total parameters and 36 billion parameters are active. 12 trillion tokens, which uh, this might this will take a lot of money and time, of course. So with this website, you can just download and use the models they have retained and just use it freely. Some of it is paid, but most of it is free. So for this session, we will going we will use this repository of Twitter robot based sentiment of Twitter tweets. This model is trained from uh, on 124 million tweets. So there's a lot. So this should be better than once we have trained out by yourself on our synthetic datasets. So uh, we want to, of course, try to use this dataset. On that we can just ask ChatGPT. Let me see. Gimana? Oh, sorry. I'm this one. Um, let's start the prompting. For the first prompt, we will ask ChatGPT to write a code to use this repo from Hugging Face. Oh, let me copy the link for the repository first. This is the model we are going to use. I'm sorry. Basically, this is kind of the same with GitHub and whatnot. With they have repositories and their users, and you can just clone it. Apa? Uh, Clone it to your own machines. And this in this example, this is a model that you have that you can clone to your own machines. I see. Okay. Let me copy the repository name. Okay. Like this on Google Colab to give uh, the ChatGPT some context. Okay. Uh, they are importing a library called Transformers. This is a crucial library if you want to use Hugging Face. They are listed. The usage is listed on this documentation and especially the Python library. In here you can see the guides of using the repositories and what's it called data set if you want to use. You can also use this for managing your as what's it called if you want to save your own files or data set or even your own pre-trained models and you want to share it, you can also use this Hugging Face so everyone can also take a look on your works. And that's basically it for like what this website does. It's quite powerful. Oh, let's see the code. Sorry. Let's see. They're connecting. Let's connect to the Colab database, Colab internet first for connect session. I mean, we are installing the transformers, and we can just as simple as this tree line to load the. We can just use the two line. I mean, to load the pre-trained model that we are going to use. Because these models are obviously better than everything since we create everything. I mean, this is better than everything we have created. So it's better to use the existing models, and what we can do is improve the models with something like with attention transformer, like we just learned. So we don't have to learn it train the model from scratch. Let's see. Uh, this is downloading installing the packages. All right. This might take a while for this downloaded. In the meantime, let me copy the prompt so everyone can do it with me. Let's. Ah, all right. They are initiating the model. This shouldn't take that long. Okay, it's already finished, and we have example input for the model. In this example is I love using this model from Hugging Face. Uh, it tokenized the input. Tokenize is because the model accepts integers. It's mandatory to tokenize the text you are going to input to the model first. And it spit out it returns the output of the predicted model. And this one, it has either negative, neutral, or positive, or three results. Let's see if we can create a function that accepts the text and returns the predicted sentiment. Right, install to creating a function to test the model with new sentence and returns predicted sentiment. Let's see. Let's copy the code. This is going to make our life easier. Well, let's see if we change this sentence. Buses are nice. Positive, and let's see if it's going to be bad one. Terrible. Okay, this is to show the model works. What if we want to see this model? We are using the what's it called, the accuracy of this model we are using. You can just attribute it to write in a cell to see the accuracy of this model. Sorry, that one. Let me copy this prompt first. One sec, and this one also. Okay. They are using a list for testing. Unfortunately, the model we have doesn't give us a test data set to compare our model and see the accuracy. But let me see if we can ask ChatGPT to use one from an online public repository. ChatGPT get a test dataset. for from public repository. Oh, you're using this GitHub user, and let's see, it works. Okay, no such file found. We see. Oh, not found. Let's check the URL if it's valid. Not that one. Uh, this one. See? Oh, not on here. I mean, on here. Not found. Let's see if we can use another. Use another data set from another source. They're using movie reviews. If it's going to be good or bad on the sentiment. Let's use this code instead. They have total number of documents. Let's see. So they have 2000s, and they're not using, let's see. Use the, let me see, documents as a test for our Twitter sentiment model. Let's see if we can see the accuracy from this other dataset. Ah, this is definitely not the same. Let's just stick with the original list dataset we have like before. Use the list as dataset like before. Not this one. I mean, let's see if we can get a better query. Let me see what's not this one. Like this one. Like this one. See. Okay. They are not giving us what we want, but let me see if we can do test the accuracy. Still error, but I put models on dataset. I put models on the dataset that they are not using on. It is not listed on this code. Let me see. Or we can just use this one sec, this this one, and just edit this the next prompt to create a bigger list. All right, this is what we want. Let me copy this prompt first, and also the second one. And let us see. Using this. Oh, this one is big, big. Let's just copy this part of large data set. Oh, it stopped. I hope it doesn't generate too much or my oh god. I stop there and we can just copy a part of this prompt probably there and let's close this. Okay. It doesn't throw error and just copy this part of the result. 1 second. Let's copy this function and see if dataset is found. Ah, we are using call. Oh, let me change this to just dataset. While we wait, we can try to implement the thing we're going to do anyway. Uh, you can just add ChatGPT. Okay, for this one, it have around 80% of accuracy. And let's see, write a new cell to implement attention transformer class on the pre-trained model with PyTorch. Okay, they are using a neural network module and creating the class and creating the attention transformer of our model. Let's see. Let's copy the code. Okay, it throws an error. Let's copy this line and also the error message. Let me copy those from first, the bigger list, and Python install to implement the attention transformer. Let's see. Let's copy the code. This works on same error. So let's try this one more time. We hope the implementation that ChatGPT gave us works. My bad. This one. Okay. And the same error. Let's see. Error on torch like on outputs. Let's hope that this one works. Okay, same problem. For this one, maybe let me get my already done uh, implementation of attention transformer. Oh, 1 second. To see the result of attention, the application of attention transformer. Like this one, let's see. It should work. Thing is with ChatGPT, it might randomize or doesn't give off the same result every time. But if you try to regenerate the response many times, maybe it will work, or you can just debug it like I did with error and pointing out to ChatGPT. And next thing is what this result means. Let me see. Compare the result with one before using attention transformer. I see the comparison. It's pretty cool. Okay, so without attention transformer shape, was it different with before? Let's see. I think they're still using the previous ChatGPT answer, but let me show you this one. Let's see. But for this one, it is using the same data set and the same training test and the same implementation of attention transformer. On this one, the context vector shape for ones with attention transformer is 1 by 768, while the original model has only 3. This one only give the result of the 3 sentiment analysis classification of neutral, positive, or negative, while ones with attention transformer give us 768. What does that means? I mean, I'm sorry. That it gives off more context about the model, why they are choosing the classification they choose. So for this one, because we have some more context other than the classifications, we can train train other models and uh, improve this model, or use the context for some other uses. So it's going to be better. Like this one, this is the result of using the attention transformer, not just 0, 1, or 2. Maybe that's all for this session of this course. Thank you, everyone. I hope everyone can leave the room, the Zoom, because it is going to be used for another class. Thank you.